Maybe we don't even need to use SQL injection to break your website. You're doing it yourself. So SQL injection attacks exploit weaknesses in web applications that fail to adequately scrutinize text that end users enter into search boxes and other web fields. These attacks have the effect of passing powerful commands to the database. This time they got the concept absolutely correct. So sometimes people get what SQL injection is, sometimes they don't. But it's something we need to be educated about and on the defense front. Here's another big one. DBAs and developers are just different, so get over it. If I go into a development shop and take a look, this picture sort of describes what I see in many cases. You have the DBA in black, who's watching the evil developers over there, and the developer is spying on the DBA to try and figure out what they're doing. They don't work together. They work against each other. This is where a lot of problems happen. So the next couple of points are done in an opposite fashion. They're not what to do. They're a worst practice. But this is what I see a lot of times. DBAs think their job is protect the database from the developers. The developers don't know what they're doing. I need to set up a wall between them and the database. Make sure that they don't do anything bad. Outlaw features. They might use them wrong. Views are bad. I had a bad experience with a view once. Views are outlawed. Stored procedures, outlawed those. Anything added after version 6 in 1993, don't want to use them. You can't use any feature until it's at least 5 versions old. This is software, not wine. You don't have to let it age to get to a nice, mature flavor. It's not the job of the DBA to educate. The DBAs, you actually know what the database is and does. You should be wanting to teach the developers about the database, how it operates. Give them that knowledge. Don't hold it in. DBA, go ahead and just say no. You stand there. No, you can't do that. You don't need to explain why. You don't need to teach them why. You're the DBA. You own the database. These are perfectly good reasons to avoid using a database feature. On the train, on the way home, I overheard somebody talking about their brother whose friend has a cousin that heard something was slow. Right? So we're not going to use that feature. Or I heard that it was buggy. This happens a lot. Educate yourself. Try the feature out. Benchmark it. Prototype it. See what it does. And developers. It's true. The DBAs are not there to work with you. They're evil. Avoid them at all costs. Right? Put up your own firewall. Figure out ways to do things without asking the DBA to help you. So even if the database already does what you need, if you need an extra privilege to do that, forget it. Don't use the database to do that, because to get that privilege, you'll have to talk with the DBA, and that's not any good. So just re-implement all those database features. Try to avoid having to work with them, such as don't ask any questions. Do as much as you can outside the database, not using the built-in features. Don't write joins. You can write code to do joins. Besides, you get paid to write code. If you start using SQL efficiently, you're not going to write nearly as much code. Don't use the database. You can write more code. Don't use integrity constraints in the database. You can write code. That's how you're going to end up with duplicate student records, by the way, if you try to do it in the application, not in the database. Try to be very generic and general purpose. Even though specific code will be hundreds of times faster, make everything really generic. And remember, this is the important one. DBAs are responsible for performance, scalability, and security. You are not. You make screens, they take care of the rest. so don't worry about that. These last couple of slides, by the way, remember, they're the opposite of what is true. But this is the attitude or feeling I see in many DBA developer shops. And the successful teams I see are where the DBAs and the developers actually sit together in the same room. They share the same floor in the building. They talk to each other. The developers have their code reviewed with the DBAs. The DBAs review their changes with the developers, that everybody knows what's going on. And lastly, a word on best practices. Everybody is looking for best practices. If I could have a list of best practices in Oracle, I would be very successful. That's what a lot of people think. And here was the definition of best practices that I found. It's a consensus of expert opinions based on actual experience. It's lessons learned, proven practices, baseline configuration rules, things I need to do before tuning, prerequisites for tuning. So far it sounds all good. If I have a list of best practices, this is all good stuff. I'll be able to use it immediately. I found this definition. That was the first page of it. The second page continued on with, but it's easy to forget that once somebody has a practice that's been branded as best, that it may represent trade-offs, noteworthy downside potential. Meaning, one person's best practice is another person's performance nightmare. The best practice was developed with what we call a context, a certain set of conditions. This is a best practice when these 500 things are true. If these 500 things are not true, this is not the best practice anymore. And so what we need to know when we're looking at these best practices is, when do they apply? And as importantly, when don't they apply? Because if I get that best practice, and I don't know what the context was, I might apply that best practice in an inappropriate context. This definition was written by a guy named Bob Sneed, who did Oracle performance on Sun operating systems. So he's been doing this for years. He wrote this definition quite a few years ago. He's a really good performance tuner, and he wrote lots of papers. But he would put this in the white papers he would write, just as a warning. Warning, if you read this paper, don't do everything I did. Because I was working on this system that was running this workload for this many users, with this type of disk array, using this much memory, and this service level agreement. If you're not exactly like this, this is just a case study for you. It's not telling you how you should do your system. It's all of these things are true, then this was the best approach, and here's why. And so with these best practices, we have to be careful. A friend of mine, Brendan Llewellyn, he is the PL SQL product manager. He owns the PL SQL language. He owns PL SQL to such a degree that when 11G was first coming out, he came to me and said, Tom, you use PL SQL a lot. You promote it. You like that. You may have 3 features added to the language. That's how much he owns PL SQL. He came to me and said, I can give him 3 things to add to the language, and he'll make it happen. Right? So this is a guy who knows PL SQL. And when he was at Oracle Open World, he was giving a PL SQL best practices presentation. And this was his list of things that must be true before you can use his best practices. He said, I'm going to give you a list. And if you don't meet the criteria in this list, you should leave my presentation because you can't use my best practices yet. So here was his list. He said, first, you have to have chosen the right parents. You have to come from a good background. Okay? So you have to have good genes, if you will. You have to have natural common sense and well